Okay, some more problems from the worksheet number 3. And there's no typos on these, so I think I'm fairly safe. So let's take a look at these. So I have two givens. C is the midpoint of AE, and C is the midpoint of BD. So that means I'm going to have congruent segments because the midpoint will give me two congruent segments. So what I'm going to do is kind of break these up so everything makes a little bit more sense as far as side angle side or angle side angle, the way I'm going to do that. So first of all, if C is the midpoint of AE, that means it breaks it up into two congruent segments, this one and this one. That's why the little marks to help you. So I know that AC is congruent to EC. So AC is congruent to ACEC. And why is that? That's the definition of a midpoint. Definition, midpoint. Okay, a midpoint divides a segment into two congruent segments. Okay, now that gives me a side. Now I've got, like I said, two ways to do these triangles right now to prove these triangles congruent, either by side, 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 or side angle, side. It doesn't look like I'm going to get any side over here, but I do have, what do we call these kinds of angles? Some of our favorites, vertical angles. And remember, vertical angles are congruent, so you can just observe that. So you can say that angle ACB is congruent to angle, so ACB ECD. So I try to keep the correspondence the same. So I'm going through one side of the angle, or one mark in the angle, one mark in the angle, ECD. You don't have to, but it's the way the triangles will be in correspondence, so it's good to do that. And that's going to be vertical angles are congruent. Could abbreviate that VERT if I want. So that's going to give me an angle. That's why I did my other given over here. My other given is that C is the midpoint of BD. There's BD. All right, one of my cats is probably hungry, so I better feed him pretty soon. Anyway, so C is the midpoint of BD. So that means that these segments are congruent, BC and DC. So BC is congruent to DC. BC and DC. And why? Again, that's a definition, midpoint of the midpoint. And that's going to give me another side. So this is why I kind of did them in this order. So it kind of looks like side angle side. It's not necessary to do that. I just don't want you to get confused, because if you did the two sides first, you use the two midpoints, you would have side, side angle. You'd have to realize that it's going to still be side angle side, because there is no side, side angle congruence for triangles postulate. Okay? All right. So we have side angle side, so we're pretty much done. So we know the triangle ABC is congruent to triangle EDC, ABC, EDC. All right, so there you go. Remember, if we look at ABC, we're going kind of like through a right angle and over to the two marks, and right angle over through the two marks. So we want to make sure that correspondence lines up. And we'll talk more about that a little bit later, because that's going to be really important as we continue with these proofs. Okay, and then the last one. Okay, number 6. Given that BC is congruent to DC, so that was given, so I already put that down here. BC is congruent to DC. So that was given, that gives me a side, because again, we're trying to prove these triangles. ABC is congruent to triangle ADC. So that gives me a side. I wrote my givens here. All right. You don't really need these. Semicolon, sorry about that. So it's given. Okay, and then AC is the bisector of angle BCD. So here's angle BCD, and AC is the bisector, so that means it divides this angle into two congruent angles. Remember, bisector cuts an angle into two congruent parts, so I can say that because this is the bisector of this big angle, I know that angle BCA is congruent to angle DCA, and that's definition of an angle bisector. Angle. In other words, it divides the angle into two congruent parts, or two congruent angles. That's what an angle bisector does. It divides it into two equal angles, or equal in measure. So that gives me an angle. And I need a side, and there's our old reflexive property again, because AC is in both triangles. It's a common side. It's in triangle ABC, and it's also in triangle ADC. So I can say that AC is congruent to AC. Oops. AC is congruent to AC, and that's just going to be reflexive property. Of congruence, and that gives me my side. I'll mark that with 2 marks here. So it looks like I've got side, angle, side, side, angle, side. So therefore these two triangles are congruent by side, angle, side, and the triangles in question were ABC, triangle ABC is congruent to triangle ADC. There you go. Okay. So hope that helps.